Hello friends, welcome to the channel Solve Mind Physics, and in today's video we will be discussing with you the short answer type questions of limits and derivatives. The very short ones, MCQs, and all the formulas related to this chapter of class 11th of limits and derivatives have already been discussed in the previous videos. So in this video we will be discussing the two markers. So we have the first question, that is differentiate sin x upon x. We have to differentiate it with respect to x. So we can apply the quotient rule here. If I consider y as y is equal to sin x upon x, then differentiation of y with respect to x will be differentiation of sin x upon x with respect to x. Okay, then we'll apply the quotient rule here. Then first we differentiate sin x. Sin x becomes cos x, and this x will be multiplied. It will remain cos x multiplied by x minus. Now we differentiate x. Differentiation of x is 1. We'll have only, and multiplied by sin x, it will be only sin x upon by, it will be divided by the denominator's square. It is x square. So your final answer becomes x cos x minus sin x divided by x square. This is the answer to the question. Then hope you have noted it down. Now let's move on to the next question. Next question is again differentiation of x cube plus 3 cube plus 3 to the power x. So again, if I consider y as x cube plus 3 cube plus 3 to the power x, then differentiation of y with respect to x will be, first we differentiate x cube. As you know the formula, x to the power n is equal to nx n minus 1, that I have already discussed. X cube will become 3x 3 minus 1. 3 cube, as it's only a constant, no x, then it becomes 0. Now this is the part that you have to differentiate carefully. Let me remind you of the formula, that differentiation of ax with respect to x, a is a constant, equals to a to the power x log a, which means differentiation of 3x will be 3 to the power x log 3. So on simplifying this, we get as 3x squared plus 3x log 3. This is the answer to the question. Note it down. I am writing the next question below. Here the first question, the second question has been solved. The next question is differentiation of sine square x cube plus x minus 1 plus 1 by sec square x cube plus x minus 1. This is the question that we have here. So you might be thinking that it's a very long term, but it will be done in only 2 steps. First step, that is sec square becomes 1 by sec square to the power any 1 by sec square x cube plus x plus 1 becomes cos square x cube plus x square plus 1, which means sine square x cube plus x minus 1 plus cos square x cube plus x minus 1. This becomes, because 1 by sec square upon x cube plus x minus 1 equals to sec cos square x cube plus x minus 1. Now let me consider this whole part as a. Then it will be sine square a plus cos square a. And using the identity sine square x plus cos square x equals to 1, this becomes 1. Now if I differentiate 1 on differentiating, I'm writing it down over here. On differentiating d1 by dx equals to 0. So the answer to this question was 0. Note it down so that I can erase it and we'll move on to the next question. Next question is differentiation of x by x to the power a upon x to the power b multiplied by it is x to the power a divided by x to the power b to the power the whole expression is to the power a plus b multiplied by x to the power b upon x to the power c. Again, this whole thing, it is to the power b plus c, and the third is x to the power c upon x to the power a, and this whole thing is again to the power c plus a. Now we are told to differentiate this one. What you simply do is, first you bring the denominator up, so it becomes x to the power a minus b to the power a plus b multiplied by x to the power b minus c to the power b plus c, again multiplied by x to the power c minus a to the power c plus a. Again, now we use the formula a minus b multiplied by a plus b is equal to x to the power a square minus b square multiplied by x b square minus c square multiplied by x c square minus a square. Now if you multiply the bases and if the bases are same and if you multiply them, you know the powers get added. So it becomes x to the power a square minus b square plus b square minus c square plus c square minus a square. And on solving this, a minus a, this gets cancelled out, minus b plus b, this gets cancelled out, minus c plus c, this gets cancelled out. So it becomes x to the power 0, that is 1. And if you differentiate 1, it will be 0, which means on differentiating, we get answer as 0. Because differentiation of any constant results in 1. I mean to say 0. So the answer will be that if this expression is differentiated, you'll get the answer as 0. Now note it down, I'm erasing it and we'll move on to the next part. The next question is differentiate 1 upon 1 plus x to the power b minus a plus x to the power c minus a plus 1 to the power 1 plus x to the power a minus b plus x to the power c minus b and last one is 1 plus again plus 1 upon 1 plus x to the power a minus c plus x to the power b minus c. We have the expression as you can see on the board. Now we have to differentiate it. So for this part, what we do is we can write this as 1 upon 1 plus x to the power b upon x to the power a plus x to the power c upon x to the power a. Similarly, the second and third terms can be written as the same, that is 1 plus, that is plus 1 upon 1 plus x to the power a upon x to the power b plus x to the power c upon x to the power b and added by 1 upon 1 plus x to the power a upon x to the power c plus x to the power b upon x to the power c. We have now expanded these terms. So if we take the LCM, it will become x to the power a plus x to the power b. It will become 1 upon x to the power a plus x to the power b plus x to the power c divided by x to the power a. And this will become 1 upon x to the power b plus x to the power a plus x to the power c divided by x to the power b. And this part becomes 1 upon x to the power c plus x to the power a plus x to the power b divided by x to the power c. All these below ones will go in the numerator. It becomes x to the power a. Means I'm here solving the whole part. As you can see, if these go upstairs, this x to the power a, this x to the power b, and this x to the power c, if these go upstairs, then we have the remainder as x to the power a plus b. It will be x to the power a plus x to the power b plus x to the power c for all the three terms, which means the denominator will become the same. So if you solve it, you will get it as x to the power a plus x to the power b plus x to the power c divided by x to the power a plus x to the power b plus x to the power c. And this whole term will get cancelled out and will become 1. And now we have been asked to differentiate it. So if we differentiate 1 d1, if we differentiate 1 with respect to x, it comes out to be 0. This is the answer for the differentiation of this question. Note it down. Now I'll erase it so that we can move on to the next question. The next question is, find derivative of x by first principle. We have been given a question to find the derivative of x by the first principle. So if I write fx equals to x, okay, and the second is f x plus h equals to x plus h. Here h is tending to 0, that is h is a very small quantity, that is almost equal to 0. And as you know, by the first principle method, the formula is that derivative of any function equals to f x plus h minus fx divided by h, and the limit is that h is tending to 0. Okay, so from what we have fx plus h, from this equation we get that fx plus h equals to x plus h, and first we write that the limit is h is tending to 0. Now we write the value of fx plus h. This value, as you know, is x plus h. It will be x plus h minus, what is the value of fx? Fx, you can see the values are here. It is x. It becomes x plus h minus x and is divided by h. X and minus x is cancelled out. What we have remaining is only h by h. H by h means you can say that this is 1. So this was the answer, that the derivative of x by first principle has been found out and the answer is 1. And you can, if you can verify it by, as you know, the derivative of x with respect, if we differentiate x with respect to x, it becomes 1. So this answer and this answer are matching, which means this has been proved and we have found out the value that the derivative of x by the first principle is 1. Now erasing this, and we'll move on to the next question. The next question is limit x tends to 1, x to the power 4 minus 1 upon x to the power x minus 1 equals to x to the power 3 minus k to the power 3 divided by x to the power 2 minus k to the power 2. This is our equation that we have been given, and they are asking us to find out the value of k. Okay, so the question is given that we have to find out the value of k. Now if I take, now it will be easy that if I consider one side at a time. So if I take the LHS, here I am taking the LHS, we can write x4 as the same, 1 can be written as minus 1 to the power 4 and x minus 1 will be the same. Here I am only considering the LHS first. As you know, we are using the formula x to the power n minus a to the power n upon x to the x minus a equals to nx n a n minus 1. Here let me repeat the formula. X to the power n minus a to the power n upon x minus a is equal to na n minus 1. You all know this formula as it has been discussed a lot of times. Here n is 4, so I write down 4 and then a is 1. Okay, and n minus 1 means 4 to the power minus 1. It becomes 4 multiplied by 1 cube, which is 4. So we have the value of LHS, that is 4. I'll write down the value of LHS here, so it will be easy to remember. Value of LHS we have got is 4. The value has been written here. Now we consider the RHS side. For RHS, what we do, we divide the numerator and denominator by x minus k. That becomes x cube minus k cube divided by x minus k, and this whole is divided by x square minus k square divided by x minus k. And again the same formula is applied. It becomes 3k 3 minus 1 divided by 2k 2 minus 1, which means 3 by 2 k square by k. It is 3 by 2k. The value of RHS is 3 by 2k. Now we have been given that these two terms are equal. That means 4 equals to 3 by 2k. 4 is the final value of LHS that has been found out, and this is the final value of RHS that has been found out. From this, if we calculate, the value of k equals to 8 by 3. This is the answer. Note it down and we'll move on to the next question. Now the next question is limit x tending to 0 under root 1 plus x minus 1 upon x. We have to find out the value of this question. Now x is tending to 0, so we can't just put the value of x, otherwise it will be in 0 by 0 form, and which means it will be not defined. So what we do here, we add plus 1 and minus 1 to the denominator. That means under root, I can write under root 1 plus x as 1 plus x to the power 1 by 2 and 1 to the power 1 by 2. It will remain the same because 1 to the power any number is 1. And below it will be 1 plus x minus 1. You can see that no difference has been made, because if you add and subtract 1, it will result in 0. So again, if I consider this whole part as y and this whole part as a, let me write it down. Considering 1 plus x equals to y and 1 equals to a, which means, and let me add the limit, y is tending to, again y is tending to 0, or you can say I'm considering that y tends to 1. That will be much better. Y is tending to 1. Limit y tends to 1, y to the power 1 by 2 minus a to the power 1 by 2 divided by y minus 1. Okay, same formula, any variable to the power n minus a constant to the power n upon the same variable minus the same constant gives you the n minus 1. That formula we are using it. It will become half a half minus 1. So what I do is I simply put down the value of a, and 1 by 2 minus 1 means minus 1 by 2. A means 1. It will be half 1 to the power minus 1 by 2. And as you know, 1 to the power any number is 1. The answer is 1 by 2. This is the final answer to the solution. Which means if this formula, I am going to say if this expression is derived with the limit given that x is tending to 0, then the answer will be 1 by 2. Now, moving on to the next question. The next question is x minus 1 multiplied by x plus 1 multiplied by x square plus 1 again multiplied by x to the power 4 minus 1. They are asking us to differentiate this expression with respect to x. So y equals to x minus 1, as you know, x minus 1 and x plus 1, it becomes x square minus 1 multiplied by x square plus 1 multiplied by x to the power 4 is actually plus 1 here, plus 1. Again x square minus 1 and x square plus 1, it becomes x4 minus 1 x to the power 4 plus 1. Again using the same formula, it becomes x to the power 8 minus 1. This is the final value of y. Now we have to differentiate it. Differentiating with respect to x, dy by dx equals to d x to the power 8 minus 1 upon dx. Differentiation of 1 is 0, so no need to consider this part. You can hide this part, and you have only one part left, that is x to the power 8, which means only x to the power 8 is left and you have to solve it. So differentiation of x to the power 8 means 8 x to the power 7. This is the final answer for the question. So this was all with today's video. All the 2 markers that are important from this chapter from the examination point of view have been discussed with you, and the next video will be on the 4 markers, which means a long answer, and the 6 markers also. Till then, goodbye, take care of yourselves, and thank you.